So there's another trivial situation when the work done is actually 0, which is when there is no displacement. So if you apply a force but there is no displacement, then work done is still going to be 0. Like if I was holding something in my hand and standing still, then I do no work in holding the object. So to summarize, work done is calculated by the force times displacement times cosine theta, where theta is the angle between the force vector and displacement vector. So in each problem you have to draw the force vector and the displacement vector and look for the angle between them so that you can substitute that correctly. The SI unit of work is the unit of force times the unit of displacement, because cosine theta is just a number. The unit of force is Newton, the unit of displacement is meter. So the SI unit of work is Newton meter, which is also abbreviated as a joule. So you can write the units of work as joule or Newton meter. So let's just do one example problem. So we have an object that is sitting on the floor that is say 10 kilograms, and a person applies a force of 25 newtons on it, and it moves, and the coefficient of kinetic friction is, let us say, 0.3. So we know that the gravitational force is mass times 9.8, so therefore 10 times 9.8, which is 98 newtons. And because this box is not having a vertical acceleration, the normal force exerted by the floor on the box is also equal to 98 newtons. And we can find the Fk, the force resisting the motion, as mu k times Fn. So that'll be 0.3 times 98, which should be 29.4 newtons. So, and the object was moving already, and let's say the object is having a displacement of 10 meters. So which of these forces do work? If you look at the normal force is upward and the displacement is to the right. So the angle between normal force and displacement is 90 degrees. So the normal force is not going to do work. So the work done by the normal force is 0. Same is the case with gravity. For gravity, it's downwards and the displacement is this way. So there is a 90-degree angle between force and displacement. So gravity also does no work. What about the applied force? The displacement is this way, so applied force is going to do positive work. So applied force, the work done is force times displacement times cosine theta. So therefore it is 25 times 10 times the angle between the two vectors in same direction is 0. Cosine 0 is 1. So the applied force does 250 joules of work. What about friction? Friction goes to the left, whereas the displacement is to the right. So the angle between the two is 180 degrees. So work done by friction will be Fd cosine theta again, which is 29.4 newtons times 10 times cosine 180 is negative 1. So that gives negative 294 joules. So the net work is negative 294 plus 250 joules, which is negative 44 joules. So the total work done on the object is going to be negative 44, which is the reason why it slows down.